Okay, I'm going to trade these again in order to preserve the ordering 1 through 5. And now I have a sixth property that I want to talk about. This one is called estimation. And it says the following. If f of x is less than or equal to g of x, then the integral from a to b of f of x dx is less than or equal to the integral from a to b of g of x dx. Now this one says that if I'm going more slowly than you, then you go farther than I do. Okay? That's all it's saying. For this one, you'd better have A is less than B. You need it because we flip the signs when we flip the order of A and B. So this one, it's essential that the lower limit be smaller than the upper limit. But let me just emphasize, because we're dealing with the generalities of this, actually, if one of these is negative and the other one is negative, then it also works. Okay? This one ends up being, if f is more negative than g, then this added up thing is more negative than that one. Okay? Again, under the assumption that a is less than b. All right? So it's as I wrote it, it's in full generality. All right, let's illustrate this one. And then we have one more property to learn after that. So let me give you an example of estimation. The example is the same as one that I already gave you. But this time, because we have the tool of integration, we can just follow our noses, and it works. I start with the inequality. So I'm trying to illustrate estimation, so I want to start with an inequality, which is what the hypothesis is here. And I'm going to integrate the inequality to get this conclusion and see what conclusion it is. The inequality that I want to take is that e to the x is greater than or equal to 1 for x greater than or equal to 0. That's going to be our starting place. And now I'm going to integrate it. That is, I'm going to use estimation to see what that gives. Well, I'm going to integrate, say, from 0 to b. I can't integrate below 0 because it's only true above 0. This is e to the x dx greater than or equal to the integral from 0 to b of 1 dx. All right, let's work out what each of these is. The first one, e to the x dx, is the antiderivative is e to the x evaluated at 0 and b. So that's e to the b minus e to the 0, which is e to the b minus 1. The other one, you're supposed to be able to get by the rectangle law. This is one rectangle of base b and height 1. So the answer is b. Or you can do it by antiderivatives. But it's b. That means that our inequality says, if I just combine these two things together, that e to the b minus 1 is greater than or equal to b. And that's the same thing as e to the b is greater than or equal to 1 plus b. Again, this only works for b greater than or equal to 0. Notice that if b were negative, this would be a well-defined quantity. But this estimation would be false. All right? We need that the b be bigger than 0 in order for this to make sense. So this was used. And that's a good thing because this inequality is suspect. Actually, it turns out to be true when b is negative. But we certainly didn't prove it.